In this learning objective, we're going to continue our exploration of sinusoidal graphs. And we're going to start looking at inside the parentheses now. What happens if we multiply inside the parentheses? So this is kind of the simplest case when we just have that, but if we combine it with our other things, we can have a full sinusoidal function that looks something like that. All right, so here's some different sinusoidal functions. We have sine of x in red. We have 2 sine of x in blue. Sine of 4x in green. Inside of 1/2 x in black. Okay. So it's kind of hard to see what's going on, but let's just focus first on the original red and the blue one. So I'm going to highlight the blue one just to make it a little bit easier to see. All right. So if we compare that to our original sine graph, you can see the waves aren't changing. It's not moving up and down, but what it looks like is you kind of accordioned the graph and you're kind of squeezing it in. So you took that red wave and you're squeezing it in. And what is actually changing is how often it repeats. So if you look at our red graph from here to here, it does one of those sine waves. But for the blue graph from here to here, it does one of those sine waves. All right, so it's changing how often it repeats. It happens quicker than the red graph. For my green graph, it would take from there to there. No, sorry, from there to there to repeat. So that's even quicker because 4 is a bigger number than 2, which is a bigger number than 1. 1/2 is a smaller number, so now it takes from here all the way out to here for that to repeat. All right, so the bigger the number, the faster it repeats, like the green one. The smaller number, it takes longer to repeat. There's actually a formula here. So the thing that is happening, we mentioned this when we first talked about the graphs of sine and cosine. They're called periodic because they repeat. So what's changing in these sinusoidal graphs is the period. It's just changing how often they repeat. The original sine graph repeats every 2 pi. That's a circle in radians. And once we start changing up that, the formula is the period, how often it repeats, is 2 pi divided by whatever b value. Remember, b is the number that's in this parentheses. And there's something we'll have to do later that this formula also works backwards. The b value in here is 2 pi divided by whatever the period is. All right, but this little formula is what's going to be important for this video. 2 pi divided by b tells you the new period, how often your graph repeats. All right, so one of the things you'll have to do is identify the period of a sinusoidal function. So I'm given this sinusoidal function, what is the period? So the first thing to do is identify b. All right, so let's do that for all 4 of these at the same time. B is the number you're multiplying your x by. So in this case, b, let's use the highlighter, b is going to be 8/3. All right, that's going to be my b here. What's multiplying by x in this one? 6 pi over 5 is being multiplied by x. Right. Next one, 2 pi over 5 is being multiplied by x. Next one, pi is being multiplied by x. All right, so all of these are my b. All right, step 2 is do 2 pi divided by b. And step 3 is just to simplify. All right, so now that I know my b value, I know my new period is going to be 2 pi divided by 8/3. Dividing by a fraction is the same as multiplying by its reciprocal. All right, so that's going to come up a lot in these because a lot of these are fractions. 2 pi times 3 is 6 pi over 8, which turns into 3 pi over 4. All right, so this function is going to repeat every 3 pi over 4 if I were to graph it. All right, this one, 2 pi over 6 pi over 5 is 2 pi times 5 over 6 pi, where we just flip that bottom fraction and make it multiplication. Those cancel. It can be 10/6, which is 5/3. So this graph is going to repeat every 5/3. Next one, again, nothing's really changing. 2 pi over 5. This is actually really similar. 2 pi times 5/2 pi. Here, the whole 2 pi's just cancel, and this one's just going to repeat every 5. Every 5 units, this graph will repeat. And the last one, 2 pi over what I'm multiplying by. Here, the pi's just cancel, and I get 2. So this one's going to repeat every 2. All right, so this is the process for identifying the period when you're given a graph. Knowing how often a graph repeats is important information, so this is one of the things we have to know how to do. The next thing is identifying the period of a graph. So I'm given the graph, what's the period? What I think about is the period is how long it takes you to get back to where you started. So you can start anywhere. A lot of times you start at 0. So how long does it take me to get back to the same place? It's from there to there. And the period of this one is 6 pi because I started at 0 and I ended at 6 pi. One common mistake would be to put that point, but here I'm going upward, there I'm going downward. So that's not the same actual place. It's the same -1, but I want to be in the exact same location on my wave, and that's there at 6 pi. All right, the other way you can do it is you don't have to necessarily start at 0. You can start anywhere. One way you can do it to make it sure you don't actually pick the wrong point is always just pick the top of the wave and pick the next top of the wave. All right, so I picked the top of the waves. This one is at 12 pi. This one is at 6 pi. So if I take the difference in those, the distance between 12 pi and 6 pi is 6 pi. All right, so this one's period is 6 pi. It's how long it takes me to get between the tops of the waves. All right, so let's just do the same thing here. You can do it with the bottoms of the waves as well. Let's just do it with the bottoms so it'll be a little bit different. There's a bottom of a wave here at -2 pi, and a bottom of a wave there at 6 pi. So we take 6 pi, subtract -2 pi. All right, subtracting is taking the difference or the distance between two things, and that's 8 pi. All right, so the period of this is 8 pi. You could also see that by going from this point to that point, 0 to 8 pi. You also see it from 2 pi to 10 pi. All right, there's a bunch of different ways you can find the period of a graph. I'm going to go ahead and identify the period of this sinusoidal function. All right, the final answer you get is 2 pi. There's a lot of ways to get there. You can use the yellow points, the red points, or these green points. I used the green one, so 5 pi over 2 minus pi over 2 simplifies to 2 pi. All right, so for this learning objective, we're going to do problems on delta math. You're going to have to do 5 problems similar to the first set of examples we did, where you have to find the period from the equation, and then 5 problems where you have to identify the period from the graph.